Hello, my name is Mirka Leino and I come from Satakunta University of Applied Sciences from the west coast of Finland. I work here as a principal lecturer and head of automation research team. On this video, we are going to take a look on 3D printing, what it is and where is it used. Okay, welcome to join this 3D printing video lecture. Today, we'll take a little look at what 3D printing really is and what the different ways of doing 3D printing are. Let's start by looking at what kind of terms are used in 3D printing, or what each word means. After all, 3D printing is the generic term for this way of making some parts, pieces or products. The 3D printer, on the other hand, is then the device by which these goods are made. That image there shows one example of a 3D printer that has already printed a small portion of those 6 round cases. As a result of 3D printing, we get the article or part, which is then commonly named as a 3D print. When these words are clear, it's easier to look things forward. Well, what does 3D printing really mean? Now that we've learned 3D modeling, we know what kind of work it takes to make the model. Then, if we want to print that model, we have to export the 3D model as a file to such a so-called slicer software, which makes the model a file for the printer, in which all the layers to be printed are presented in a sequence. This way, the printer can start printing first the first layer, then the second layer, etc. That's when we are in this manufacturing process section of the image. The printer prints the parts layer by layer until the printer has done its job and we get to take the first finished part from the printer. So, why do we want to 3D print? There are actually a lot of different reasons for that, which we'll go through a little bit later, but here's one good reason. If you look at this series of pictures here, which shows how the product is made using traditional milling or turning methods. There, we first take a large enough lump of the material we want to use and then start milling or turning parts out of it. Then we are talking about the subtractive manufacturing, which is a technique where material is removed from the lump until we have the finished part or product, as we have here. That way, of course, we get the piece, but at the same time we get a really lot of waste. Because all the material that has been removed goes to waste. That's by no means desirable today, isn't it? On the other hand, if the same piece is made by printing, we initially have the material either as a powder, as in this picture, or as a plastic wire. This material is then used to print the product, and almost no part of the material is wasted. Really, however, such a small pile of waste is generated because printing sometimes requires supports that are talked about a little later. And those supports then end up as waste. In any case, the amount of waste generated in the manufacture of the piece is much less than with conventional methods. Let's take a look at the whole 3D printing process. Everything usually starts with an idea. We find that it would be nice if there was some kind of a funny piece on its own, or even if the bracket on the bike reflector breaks and it needs new one, etc. The idea can come from anywhere. First, we model the idea into the best possible model. Ensure all important things like dimensions and shapes there in the modeling program. Then we save the model in a modeling program, usually as a file with an .stl extension or, for example, .obj. This file is then taken to a slicing program, which can be found online in many free versions. The slice file is then exported to the printer and the print button is pressed. Sometimes the finished piece may have to be post-processed a bit, in other words, clean, for example, by sanding, and then we will get out our piece to use. Next, let's take a look at a bit of where 3D printing is already used. Many goldsmiths use especially 3D printing of metals. Car parts are printed. Bakeries can print, for example, 3D chocolate decorations. Shoemakers can make any kind of special insoles or shoe shapes by 3D printing. That picture there shows that hand prosthesis of the future. A lot of printed body parts have already been made, and doctors also use printed parts to help with surgeries. For example, by giving an artificial joint to the hip bone just according to the patient's size. It's really hard to figure out which industry hasn't yet used 3D printing, at least in some way. Did you come up with any such industry or area of life? You can Google after this lesson to see if there is already 3D printed stuff in that area. Before we take a closer look at the different 3D printing techniques, let's think a little more about the pros and cons of 3D printing. The good thing, at least, is that you can print almost any complex shape. Each person can print their own name on the product or other unique things. For example, in that prosthesis on the previous page, I mean in the artificial hand, the right kind of attachment and design can be made just for that person. And even the colors and patterns can be made to your liking. You don't need any pre-made molds for printing. You can try to print something today, and if it's not quite right, you can put a new version to print overnight. Still, 3D printing is not just good things. After all, printing is clearly slower than traditional casting and milling methods. And there is still quite a bit of material to be printed, even though there are more and more of them every day. Some pieces that come in really hard use are still a little weaker than the same pieces if they are made by traditional methods. On the other hand, the accuracy may not be as good either, and you can play with the equipment quite a lot if you use printers at home. Okay, then let's take a look at the different 3D printing techniques. There are really many different 3D printing techniques and their variations. Certainly several dozens. In this video, we will look at 4 different but very commonly used techniques. Of these, FDM or plastic extrusion technology is the most used in homes and schools. In addition, we will take a look to liquid resin, plastic powder and metal powder printing. Let's start with this most common technique, plastic extrusion printing. Its acronym FDM comes from the English words fused deposition modeling. The operation of plastic extrusion printer is basically really simple. It produces the part or piece by melting plastic wire and then extruding the molten plastic through the hot nozzle. In practice, this is done so that these extruder gears here pull the plastic wire from the roll into the nozzle. Typically, plastic extrusion printer uses either 1.75 mm thick or 2.85 mm thick plastic wire. Thus, when the extruder gears pull the plastic wire inside that nozzle, the nozzle is heated just enough. The temperature varies quite a bit depending on what plastic is being printed. But with commonly used PLA plastic, the nozzle is heated to approximately 200 degrees Celsius. Then at the end of the nozzle there is a small hole from which the plastic is extruded in the form of a strip on that plate. In other words, on the base where the print is formed. The size of the nozzle hole, of course, affects how thick the strip comes out of the nozzle at a time. Even the plate is heated frequently so that the print catches on well enough and does not move during the printing. The printer nozzle is then moved back and forth and to the right and left according to the information in its slicing file. Printing each layer at a time, after which the nozzle rises or the plate lowers and begins printing the next layer. Okay, then about the materials. A wide variety of plastics and their mixtures can be used as material in plastic extrusion. The most common are PLA, ABS and PET plastics. Here is one example of plastic extrusion printer. This printer can produce pieces up to 25 centimeters by 21 centimeters up to 21 centimeters in height. The height of one print layer can be varied from 0.05 millimeters to 0.35 millimeters. Thus, if a 10 centimeters high print is made with the smallest possible layer thickness, it will have 2000 layers. This printer can be purchased in parts, or in other words, as a kit that can then be assembled by yourself. Then its price is less than 800 euros. But it can also be ordered pre-assembled, in which case the price is about 1,000 euros. Here is a short video about a plastic extrusion printer in a printing job. In this printer, that orange nozzle section moves right and left and up and down. Then that checkered printing plate moves forward and backward. If you look at it very closely, you will see the small tip of the nozzle right next to the print position. There. Okay, then let's look at a few application examples for plastic extrusion printer. All sorts of game pieces and gaming aids have been really popular printable things. Then, of course, from an industry perspective, all sorts of prototypes or model pieces of different devices and products are printed a lot. It's really nice to try the product's features when you can hold the product in your hands, even if all its functions are not yet in use. Then you can quickly make changes to the model and put the new version to print even overnight. History and art have also taken advantage of 3D printing more and more recently. The shapes of the destroyed temples of some of the old Inca kingdoms have been elucidated and miniaturized by 3D printing. Here is an example of a 3D printed scale model of an old Pori house that was a secret illegal bar here in Pori over 100 years ago. All kinds of spare parts are printed a lot. On the left, you can see spare parts for one 3D printer. So you can build a printer that has been printed. On the right, on the other hand, is a test for a spare part that is not even available in the store. It is a yellow cover plate for a standard wall socket. Even complete robots have already been 3D printed, and they have become surprisingly durable. Robot grippers and tools are also 3D printed. A gripper is a robot's tool with which it grips some of the parts to be moved. Grippers can be really expensive, so a self-designed and 3D printed gripper can be a viable solution. On the right, for example, is a gripper printed for one of our robots here at SAMK. It cost maybe €1 or €2 with its suction cup. A wide variety of parts and pieces for everyday use can be 3D printed. Here you can see the fastener of a Q divider belt, known at least from airports or amusement parks. At the bottom left here is a jig that really got a fish. And at the top right, here are the 3D printed shoe soles to replace the worn ones. You can make toys of any kind when you 3D model and 3D print them by yourself. Here are toys printed on a plastic extrusion printer from a plastic with 30% wood fiber. I mean that there is 30% of food fiber among the plastic. Then the print will have such a woody looking surface. Of course, all kinds of covers and cases are also important, at least if you are building equipment by yourself. And a variety of pieces can be printed for teaching. They are intended to illustrate something that would not otherwise be in use. Here we have a printed copy of such a pressure bottle of physics laboratory here at SAMK, and of course a few copies of a human head. Now, surely the question of how long 3D printing takes turns in many of your minds. I have to say that it is, of course, affected by many things. Which printer is used, how high layers are printed at a time, how large the print is, whether the print has only covers or walls, or whether there is plastic printed inside the walls, and how much. These frogs here are examples from the website of a printer manufacturer called Prusa. That first frog here has been printed so that the height of one layer has been 0.1 millimeters. Then the printing time of a frog, which is just over 5 centimeters long, has been 1 hour and 51 minutes. When the layer height was then increased so that a 0.2 millimeter layer was printed at a time, it took only 57 minutes to print. When even higher layers were made, in other words, here 0.3 millimeter layers, the printing took only 39 minutes. However, from these circles, you can see that the higher the layer is printed at a time, the more clearly the layers are visible. This means that frog surface is not as smooth. In other words, a compromise is always sought. It is possible to handle the printing so that the exact details are printed more accurately or with a lower layer height, and then other parts are printed with higher layers. This results more accurate prints fast. Another example of a printing technique that is presented here is SLA, or stereolithography. It's a bit a difficult word, but it actually means printing with laser light. In SLA printing, the printer has a build plate, like here, a resin tank, a laser light, and mirrors, as shown here. Printing happens by placing liquid resin in that resin tank. You'll see later what it looks like in the video. There is a really precise laser beam under the tank that hardens the point where the beam hits the resin. The points of impact of the laser beam are guided by those mirrors. In other words, in which direction the mirrors turn the laser beam, from there the resin hardens. Here again, the laser hardens one layer at a time. The print sticks to that build plate at the top, which is always lifted upwards after each layer, whereby resin flows under the hardened part, which is then again hardened with a laser beam on the next layer. This is how the finished print rises up from the tank layer by layer. As I told, the material for this SLA printing is liquid resin, which is available in a few different colors. The resin is hardened by a laser beam. In other words, it hardens in light, especially in ultraviolet light. Therefore, this means that if the finished print is exposed to sunlight, it will always harden more and more, so that it can eventually become as brittle as glass. SLA prints should not be made for outdoor use, at least not without coating. Here we have the SLA printer we use here at Satakunta University of Applied Sciences. It is called Formlabs Form 1 Plus. It can be used to make prints that are a little over 10 centimeters in its square, but in them there can be pretty precise details. The price of such a printer is around 4,000 euros. MSLA is a special version of an SLA printer. Instead of a laser beam, there is a screen under the resin tank, which permits light to pass through to certain areas that needs to be hardened on each layer. This light then hardens the entire layer at a time, making printing a lot faster. Here is a video example of an MSLA printer. Initially, it has an empty resin tank, at the bottom of which you can see the first printed images illuminated. A liquid resin, which is a bit of such a gel-like substance, is then poured into the tank. And then, let's jump a bit. And then we can see how the printer build plate lowers on the surface of resin, and the printer starts printing layer by layer. So actually we can't see, or it's quite hard to see, the printing itself because it all happens between the build plate and the resin tank. Okay, let's then take a look at what SLA and MSLA printing is used for. These printing techniques are often used to make miniatures because small details are easy to see with these precise printing techniques. Likewise, jewelry and toys. At the top, for example, we have a technical Lego wheel printed here at SAMK. Different kind of molds are also made by SLA and MSLA printing because of the precision of the details. The molds can then be used, for example, in plaster casting. Here on the left you can see the basal ganglia, the part that regulates human fine motor skills in our brain. We have just printed these basal ganglia out for educational use, so that the teacher can show what those important parts of the brain look like and how they relate to each other. At the top right, there are then other parts of the human body that have been printed out so that students can hold them in their hands and get to know their shapes as accurately as possible. And dentistry uses these printing methods as well. For example, molds can be printed for dental supports. One important thing in both plastic extrusion and these SLA and MSLA prints is print supports. Only if printing is done almost straight up from the build plate can the printout be printed without the print supports shown here in this image. Of course, the printer cannot print blank. Consider, for example, a table that is printed starting from the legs of the table. Then, when it comes time to print the surface of the table, it is mostly above a blank space. Whenever you should print on a blank, the printer prints the supports that hit the build plate and then the print you want to print on it with a thin tip. As you can see here, very thin tips here and here. This allows printing to be successful and can then be removed after the printout is complete. Due to the number of print supports, it is important to think about the position in which the piece should be printed in order to print a suitable amount of support. If there are a lot of them, removing it is laborious. The slicing program often has a preview feature that allows you to test in which position you should print. By the way, you should not put the printer, for example, in a sauna. It is too hot there, and it can be difficult to set the print settings. You should always print at room temperature. Then we look at SLS printing. SLS is an abbreviation which comes from the English words selective laser sintering. So the name already tells you in fine words what this format is all about. Selective means that the printing is made by sintering according to the 3D model. Sintering with a laser means that a hot laser beam melts a material in powder form, such as some plastic, and then hardens it into a piece. Let's take a closer look. So, here you can see the build plate or the printing plate with initially one layer of plastic powder. Then, with that laser beam, the powder is melted at the points where the print is to be formed. Finally, the molten parts then harden. The laser can be moved forward and backward as well as to right and left, allowing it to hit anywhere in that build plate. After each layer, this printing bed or printing plate lowers one layer, and then that roller sweeps a new layer of powder onto the build plate. Then again, the laser melts the powder from the right places and thus proceeds layer by layer until the print is complete. Then the printout is removed from the printer and the plastic powder remains there, some of which may remain on the surface of the printout, but it leaves just by blowing or wiping lightly with a brush. There are SLS printers also for industrial use, even if they can't print any large pieces yet. Their prices are really high, and they can cost from 200,000 to over €1 million. For the price of one printer, you would get many detached houses and cars here in the countryside at their best. There are also SLS printers for home use, but their prices range from €5,000 up to 20,000, and they don't print nearly as large parts as the largest plastic extrusion printers. The last printing type viewed in this video is DMLS. DMLS is basically very similar in function to the recent SLS, but here the material is metal powder. With metal powder, the printing temperature in the chamber where the powder is actually much higher. These printers also use a method of removing oxygen from the chamber during printing. Metal printers can print at least steel, titanium, aluminium, and tool steel. New print materials are constantly being developed. There are also industrial and hobby versions of the DMLS printers. Neither can make very large prints yet, but the prices are really high. Metal printers for industrial use can cost from €200,000 to €2 million. The parts printed with these cost from a few tens for small parts to thousands and tens of thousands of euros. Now you may no longer be able to talk about home use at all, but you may be able to talk about amateur use. Even those printers cost over €50,000. A metal printer can print really complex shapes like these here, which cannot be done at all with traditional casting methods. Metal printing has quickly found its way into medicine. Various prostheses, like artificial joints, as on the left here, are printed to suit the patient by metal printing. And the last example of metal printing is from the automotive industry. There, metal printing is already used to print a wide variety of parts. This way the parts can be made truly individually. Well, this was everything on 3D printing this time. Now that you are familiar with 3D printing, you can start thinking about what kind of prints you want, and then just model it and print it to yourself.